Wanted to do a quick video on CRIs, being a retired engineer turned vet assistant, studying the vet tech curriculum the same as all of you. Maybe I can help with some of the math. I've seen comments against some other great videos on CRIs, and I think there's a couple things that will clear up the keeping track of the units, the so-called dimensional analysis. The first is text to math, and the second is how vulgar fractions are reduced. The doctor's orders are generally given in mgs per kg per hour, or minutes or days, or maybe micrograms, some unit of mass, the patient's mass, and some unit of time. And they string them out with these division symbols horizontally like this. This is text. You have to convert this to math or the units aren't going to make any sense. So what the doctors asked for is mgs per kg every hour. Write it like this and then the units will make sense. And now we get into how vulgar fractions read. Vulgar fraction, as opposed to a decimal fraction, okay? When you have a numerator and a denominator, that's called a vulgar fraction. All right, so when you have a vulgar fraction, you can multiply by the denominator, 1 over the denominator. The reciprocal of the denominator will get you the equivalent of what this is. So what that means is we take our numerator and multiply by 1 over hours. Hours was the denominator, 1 over hours is the reciprocal of the denominator. So what this gives us is megs per kg hour. This is multiplied. There's no division symbol here. This is what I see the problem in otherwise great videos on CRIs. Because they saw it up here in text form, they want to put it down here too. And then your units don't make any sense, okay? So this is like kilowatt hours, it's multiplied. So resist the temptation to put a division symbol in here. Now at this point, you're going to have an actual patient with a mass in kilograms. So multiply by kilograms at this point, the patient's mass, and kilograms over kilograms, anything divided by itself equals 1. So kilograms over kilograms equals 1, and 1 times the rest of the stuff doesn't change anything, so we're free to ignore kilograms, and we get megs per hour. But what we want is how many mils of the drug do I draw up in my syringe? So we're after mils. Well, the only place we have mils is in the concentration value on the vial of drug, and it's in mgs per mil, or maybe a percent, like lidocaine typically is 2%. Well, the convention is the percent means 2 grams per 100 mils. So that would be 2,000 milligrams per 100 mils. 100 over 100 equals 1, and it's 20 megs per mil. It's as if you added a 0 to the percent value. That's the shorthand most of us were taught. But that's why. It's the medical convention is that means 2% means 2 grams per 100 mils, or 2,000 milligrams. So it becomes, add a 0 to the percent value is 20 megs per mil. So we've got megs per hour at this point. We want mils. Now we just learned you multiply by the reciprocal of the denominator. So we know we have to divide our concentration as the denominator so that we can multiply by 1 over that, or mils per meg. Mils per meg is the reciprocal of the denominator. Megs over megs equals 1, and we got mils per hour. If only we knew how many hours, we could multiply by hours and we'd have how many mils of drug to draw up. Well, that comes from the fluid bag and the flow rate. So you may have so many milliliters in the fluid bag and a flow rate in mils per hour, or depending on what drug it is, it might be per day or minutes. But anyway, we know we want hours. That's in the denominator. How do we get that up top? Divide this into something and we can multiply by the reciprocal. So we'll make this value, our flow rate, we'll make that the denominator so that we can multiply by the reciprocal. So the mils in the bag are divided by our mils per hour so that we can make this reciprocal of the denominator, hours per mil. And mils over mils equals 1, and we're left with hours. And the hours goes up here, and that's how many mils of drug we draw up, okay? So it would probably help to put some numbers in and work through one. So I'm going to use round numbers I can do in my head. No guarantee that I won't screw it up, but our chances are improved. So we'll say 10 mg per kg per hour. We'll have a 20 kg patient. So we'll have 10 mgs per kg every hour. I'm going to multiply by the reciprocal, 1 over hours, and get 10 mgs per kg hour. Now I'm going to multiply by my 20 kgs. Kgs over kgs equals 1, and I'm up to 200 mgs per hour. Mgs per hour, the only units I have left. Now I want mils. We need a concentration. We'll say it is 2%. So I've got 20 mgs per mil concentration. So our 200 mgs per hour divided by our 20 mgs per mil, because mils is on the bottom of the denominator, I want it on the top. I put it on as the denominator so I can multiply by the reciprocal of that. The reciprocal of 20 megs per mil is 1 over 20 mils per meg. Megs over megs equals 1, and I got 20 goes into 200, 10. So I've got 10 mils per hour left here. If only we knew how many hours. Well, we'll say 50 mils per hour is our rate, and I'm going to have 200 mils in the bag. I divide this into 200 because hours is on the bottom. I make this the denominator so I can multiply by the reciprocal, and that will bring hours to the top. So we multiply by the reciprocal, 1 over 50 hours per mil. Mils over mils is 1. 50 goes into 200, 4 hours. which comes up here. Hours over hours equals 1, and I'm left with 40 mils of drug that I have to draw up. Now we're going to pull, before we draw up our drug, we're going to pull 40 mils out of our bag of 200 and leave 160. As best we can read the graduations on the bag of fluid, okay. But I read 200 right on the line. I'm going to call it 200. I'll pull 40 mils out in a syringe and discard it. And then I'll draw up my 40 mils of drug and put it in the bag. I'm back up to 200. And then 200 divided by 50 is 4 hours. If I just put that 40 mils into the 200, I'll have 240 mils. And now it'll last longer than 4 hours. In my calculation, I got to start over. It doesn't hold anymore. So you got to defend your volume in the bag by pulling out room for the, defend the volume of fluid in the bag so that the calculation holds. So the bottom line, convert text to math, write it like this, multiply by the reciprocal of the denominator, and then hopefully the dimensional analysis will make more sense. All right, hope that helps. Bye.